Example 2. A coin is tossed until a head appears, and the number of tails is recorded. Is this a binomial probability experiment? Why or why not? We'll just go through the 4 things that it needs to satisfy to be a binomial experiment and see where that takes us. So number 1 condition, there has to be a fixed specific number of trials. Now in this example, the experiment is to just toss a coin until a head appears. And every time you do that, it'll take a different number of trials to get to your first head. So right away, we're seeing a problem here, a reason this cannot be binomial. So we'll say no, because there's not a fixed specific number of trials. It will take different numbers of trials, in other words, tosses of the coin, to get a head. In the next example, we're told that a die is rolled 10 times and the random variable x records the outcome of each roll. Is this a binomial probability experiment? Why or why not? We're clearly told that the number of trials, lowercase n, is 10. So this is a fixed specific number of trials. So we're okay there. Next, we need to know that the trials are independent. And they are, because what you roll the first time is not going to affect what you roll the next time. Each die roll is a trial, and the experiment is to roll it 10 times. Anyway, the die rolls are clearly independent. So the trials are independent. Next, we need to make sure that each trial has 2 mutually exclusive outcomes. In this case, the random variable x is recording the outcome of each roll, and the outcome of a die roll is 1, 2, 3, 4, 5, and 6. That's more than 2. So as soon as we see that, we can say that this is not a binomial. Probability experiment. The next example is sort of similar. Again, we have a die that's rolled 10 times, but this time the random variable x records the number of 6s. Is this a binomial probability experiment? Well, let's see. Again, the number of trials is clearly stated to be n equals 10. This is a fixed specific number. So we're okay there. Again, the die rolls, which are the trials, are independent. They don't affect each other. And this time the outcomes, because of the way we're counting them, the outcomes are either 6, which since we're counting that, means that counts as our success, or not 6. So if you don't get a 6, that's considered to be a failure. So 6 or not 6, that's 2 possible mutually exclusive outcomes. So we're actually okay on that. And then last, we need to know that the probability of success in each trial is always the same. And the probability of success is 1 over 6 in each trial. So yes, this is a binomial probability experiment.